Hi everyone, welcome to Vocal Academy. See this problem. Here, the open loop DC gain of unit native feedback system having closed loop transfer function, that is s plus 4 upon s square plus 7s plus 13. This is the given question. So what it means, here given that closed loop transfer function, that system having unit feedback, that is negative feedback, then how can you find open loop DC gain? So this is the problem. Now how can you find the open loop DC gain for the given problem? Before going to solve problem, first of all we need to understand what is system and what it consists. So let's see here. So this is the system having, this is the open loop system G of S, and it have a feedback, that is H of S. Here input C of S and here output R of S. So here input and output are in frequency domain. Overall system will be in frequency domain. So according to this closed loop transfer function, that is equal to input by output. So output is also called as response, that is C of S by R of S. So for native feedback system, the transfer function is G of S by 1 plus G of S into H of S. So this is called as transfer function. So the ratio of input by output, it is called as a transfer function. It gives relation between input and output. So this is the transfer function, nothing but closed loop transfer function. Is given as s plus 4 by s square plus 7s plus 13. Substitute here, then we get s plus 4 upon s square plus 7s plus 13. Here we want open loop transfer function. So whenever we get open loop transfer function, so from that we can easily find the open loop DC gain. That means open loop means here G of S. So find G of S. So now we equate this transfer function with this equation, that is G of S upon 1 plus G of S into H of S. So feedback is negative, that's why here I am taking. Suppose it here it is a positive feedback, take here negative. Okay, so for this negative now I am taking positive. Now H of S is 1 because feedback is 1, it becomes s plus 4 upon s square plus 7s plus 13 equal to G of S upon 1 plus G of S. Now from this how can you find the G of S? Here simplification is very easy, just small tick apply. So that is, so in LHS inverse of it, it becomes s square plus 7s plus 13 upon s plus 4. Simultaneously apply inverse on RHS, it becomes 1 plus G of S upon G of S. Now we can divide numerator here with denominator. So it becomes s square plus 7s plus 13 upon s plus 4. Keep as it is LHS. On RHS becomes 1 by G of S plus G of S by G of S. So here I am dividing these two terms. In the numerator 1 is there, G of S is there. So these two terms are going to divide with G of S. So like this. So here G of S cancel. Now it becomes, keep LHS as it is, no change still. So s square plus 7s plus 13 upon s plus 4. Here 1 is there. So bring this one to left hand side. It becomes minus 1. That's equal to 1 upon G of S. So by simplifying this, it becomes means by taking LCM s plus 4. S square plus 7s plus 13 minus s minus 4 upon s plus 4. That's equal to 1 by g of s. So it becomes s square plus 7s minus s. It becomes 6s plus 13 minus 4. It becomes plus 9 upon s plus 4 equal to 1 by g of s. But here we want g of s. Now apply inverse on both sides. So then we get s plus 4 upon, so denominator becomes numerator, s square plus 6x plus 9, that's equal to, so 1 by g of s becomes g of s. So this is g of s, nothing but it is a open loop transfer function. So for this open loop transfer function, now how can you find gain? This is the required question. Now how can you find the gain? So DC gain will occur at omega equals 0. But here S is there. S is nothing but j omega. S means j omega because it is a frequency domain. Now substitute S means j omega. Then we get j omega plus 4 upon j omega whole square plus 6 j omega plus 9, that's equal to g of j omega. So DC gain formula is modulus, means gain is always positive. So whenever omega equal to 0, substitute omega value 0, it becomes omega into j 0, 4 in numerator, this term becomes 0, this term becomes 0, remains 9. So this is the open loop DC gain for the given problem. And this is the process of simplification. And thanks for watching. Please subscribe, like, share, thanks.